Hi, I like to improve my English by making some videos. For this first video, I have decided to talk to you about synthetic division. I'll be using the C language and for this tutorial. A link in the description will take you directly to the work page. This is a work page, a wikibook, a French wikibook. You must first download the hash file. You find here the hash file. You can then download the first example, a C file. This is the first example, a C file. Now I try to download this C file. I put the C file. Okay. I put the C file into my editor. I save it. Now I verify if it all is correct. I have all the hash file is correct and I have the C file. Synthetic division. The long division of polynomials can involve many steps and be quite cumbersome. Synthetic division is a shortcut. Synthetic division is a shortcut that can be used when the divisor is a binomial in the form x minus k. Synthetic division is a shortcut that can be used when the divisor is a binomial in the form x minus k, where k is a real number. In the synthetic division, only the coefficients of the polynomial are used in the division process. In a synthetic division, only the coefficients of the polynomial are used in the division process. Can you explain how to divide minus 3x power 2 minus 20x plus 4 divided by x minus k using the synthetic division and the C language? For this example, I write k equal minus 1. This gives x minus k, x minus minus 1, x plus 1. Yes, I try to explain this, the synthetic division. This is the first example. Alors, the polynomial we want to work on this polynomial. Okay. This polynomial is the degree of this polynomial is 2. The degree of this polynomial is 2. I want to work when k it is minus 1. I write k equal minus 1, and the coefficient of the polynomial, I write the coefficient of the polynomial in this tabular. Minus 3, minus 20, 4. Minus 3, minus 20, 4. Now I can try this example. if p of x is this polynomial, minus 3x power 2 minus 20x plus 4, the algorithm of the synthetic division is this. This is the algorithm of the synthetic division. The first thing, I must copy the coefficients of the polynomial in the synthetic division. The first coefficient, minus 3, the second coefficient, minus 20, and the first coefficient, 4. I left the second line empty, and I write in the third line the coefficients of the first coefficient, minus 3. In the first line, I copy the coefficient of the polynomial. The second line is empty, and in the first line, I copy the first coefficient, minus 3. Now, k equal minus 1, k equal minus 1, I use minus 3 multiplied by minus 1 by k. This gives plus 3. Minus 1 multiplied by minus 3 multiplied by minus 1 is 3. Now I add minus 20 plus 3. This gives minus 17. Minus 17, I multiply minus 17 by minus 1. This gives plus 17. I add 4 plus 17. This gives plus 21. This is the algorithm of the synthetic division. The result is here. You can rewrite this result in this manner. The synthetic division indicates that the result is minus 3x minus 17, the two first coefficients, and this is the remainder of the synthetic division, 21. Also, you must divide the remainder by x minus 1. Okay? The synthetic division indicates that p minus 1 equal 21. If you want to compute p of minus 1, you can use the synthetic division. Now I try to verify this. I copy the polynomial. I copy the polynomial. Now I want to compute this p of minus 1. Alors, p of minus 1. Alors, I write minus 3 minus 1 square minus 20 minus 1 plus 4. Minus 3 minus 1 square give 3. Minus 20 minus 1 plus 20 plus 4. Minus 3 plus 4 égale 1 plus 20. This gives 21. This is the result, the remainder of the synthetic division. The synthetic division indicates that p minus 1 equals 21. Now I try to change the value of k. For example, I put 2. K equal 2. And now I try to do the same work, but when k equal 2. It is the same polynomial. The first thing I must make the algorithm of the synthetic division. I copy in the first line the coefficients of the polynomial, minus 3, minus 20, and plus 4. I left the line empty. I copy in the first line the first coefficient of the polynomial, minus 3. Now k equal 2. I compute them. I multiply minus 3 by 2. I multiply 3 by 2, this gives minus 6. I multiply, now I add minus 20 plus 6, this gives minus 26. I multiply minus 26 by 2, this gives minus 52. I add 4 plus minus 52, this gives minus 48. This is the result of the synthetic division. You can write this result in this way: minus 3x minus 20, and the remainder divided by the binomial x minus 2. And the result of p of 2 is minus 48. We can try to verify. We want to compute p of 2. This gives minus 3 2 square minus 22 plus 4. Minus 3 4 minus 22 4. This gives 12 minus 12 minus 40 plus 4. This gives minus 52 plus 4. Minus 72 plus 4 if equal to minus 48. This is the remainder. This is the remainder, and also P of 2. P of 2. Voilà. First I have changed the value of K. Now I try to change the value of the coefficient of the polynomial. Instead, I put here 0. You can see the result. And perhaps I put here 1. 1 and 0. This is the new polynomials. The power of x squared is 1. The coefficient of the constant is 4. The coefficient of x is 0. Is not right. Is not right. Okay? Alors, now I must write the algorithm of the synthetic division. Alors, I have choose for K2. I have choose the coefficient 1 for x squared, 0 for x, and 4 for the constant value. Also, I write the first coefficient is squared minus 1 plus 1. The second coefficient for x is 0. You don't see it, is 0. And the coefficient for the constant is 4. Okay. I have choose to write k equal 2. Okay. Now, in the first line, I have write the coefficient of the polynomial. In the second line is empty. Now, in the third line, I write the first coefficient, plus 1. Now, I multiply plus 1 by 2. This gives 2. I add 0 plus 2 is 2. Now I multiply plus 2 by 2. This gives 4. I add 4 plus 4 is equal to 8. This is the result of the synthetic division. You can write this: x plus 2 x1 x plus 2, the constant, divided by the remainder plus the remainder 8 divided by x minus 2. Okay, and the result of the p of 2 is also the remainder 8. Here is also the remainder 8. Now, perhaps we can verify this. Fichier nouveau, permet d'enregistrer. Alors, the polynomial is square. I want to compute P of 2. Alors, ça fait x plus 4. 2 for 2, 4 plus 4. This gives 8. This is the remainder that I found here. It is also the syntactic division indicates that P of 2 equal 8. Fichier nouveau. The polynomial is x squared plus 4 equal 0. Okay? Now, I want to change this polynomial. Instead, the first coefficient 1, the second coefficient is 0, and the third coefficient is minus 4. Minus 4. Okay? Alors, this is a new polynomial that I want to work. I can factorize this polynomial in this way: x squared minus 4 equal x minus 2 x plus 2. Okay? Hello. In the same manner, I want to create the algorithm of the synthetic division. Alors, the first coefficient is 1, the second coefficient is 0, x have no coefficient, and the constant coefficient is minus 4. In the second line must be empty. Now I copy the first coefficient in the third row, first line. Now I use 2. 1 multiplied by 2, this gives 2. 0 plus 2 equal 2. 2 multiplied by 2 is 4. Minus 4 plus 4 is 0. Okay? Donc the remainder of the remainder of the synthetic division says that the remainder is 0. This is correct puisque x equal 2 and x equal minus 2 are the root of the polynomial, are the root. Okay, donc in this I have choose plus 2, and I see the remainder is 0. This is because 2 is a root of the polynomial. Now I try minus 2 with the same polynomial. The remainder is 0. This gives that minus 2 and 2 as a root of this polynomial. Why? Because I can factorize this polynomial into factor x minus 1 and x plus 1. Okay? For example, if I take 1 for k, the remainder is not 0. Why? Because 1 is not a root of this polynomial. But 2 and minus 2, the remainder is 0 because 2 is a root of this polynomial, and minus 2 is also a root of the polynomial. You don't see a root of this polynomial. Okay. I think I want to stop the video because it is difficult for me to continue. Thank you.